are going to do lesson 3 using rules of exponents. As we talked about in lesson 2, we do have to follow the order of operations, and one of them is dealing with the exponents. Now, maybe for the first time ever, you are going to deal with negative exponents. Alright, the definition of x to the negative n power, if n is any real number, it doesn't matter what it is, and x is a real number that is not 0, then we can follow this equation here. We've got x to the negative n. What that means, simply, is if you have a negative power and it's on the top, you can always get rid of that negative power by dropping it to the bottom. So this x to the negative n turns into 1 over x to the n just by dropping it to the bottom to get rid of that negative exponent. So if we look at our examples down here, we can simplify every single one of these. Alright, our first one, as you can see, in the bottom we have 5 to the negative 2 power. We want to get rid of that negative exponent, so we're going to move it to the top. We still have this 1 up here, but it's going to be times 5 squared. Because it was negative on the bottom, we moved it to the top, we got rid of the negative exponent. Now we can simplify this really easy. 5 squared is 25, times 1 is 25. We can also do the same thing for things on the top. We have 5 to the negative 2 power, we want to get rid of that negative exponent, so we're going to move it to the bottom. And it becomes 5 squared on the bottom. We don't just have an empty spot up here on the top, we've always got a 1 up there. So we put that in there, and then we just simplify this down, 1 over 25. For our next one, these two, our third one and our fourth one here, look very, very similar, but they're not the same. For this first one, just the 5 is raised to the negative 2 power. So we would have a negative out in front with a 5 dropped to the bottom and it raised to the 2 power with a 1 on top. This would end up being a negative 1 over 25. It stays negative because the negative is not raised to the squared to the second power. Alright, with our next one though, that's not the case. This number inside the parentheses raised to the negative 2 power is a negative 5 now. So the negative 5 goes down to the bottom. So we've got a negative 5 raised to the second power. Now we take negative 5 squared to get us 25 and with a 1 on top. These two are different, as you can see in our answers here. One is negative, one is positive, and it has to do with those with the parentheses. Product rule is something we use quite a bit. Whenever you have something that has the same base, that is these x's here, you can always add your exponents. So what it says here, our x's are the same, we bring the x over, we add our exponents, m plus n goes into the exponent. So if we come down here, we've got an x squared and an x to the negative third and an x to the negative fifth. We can add all of those together, and for x, we get x to the 2 plus negative 3 is negative 1, plus negative 5 is negative 6, so we'd have x to the negative 6th power. For our y, we do the same thing. We've got negative 4 plus 2 plus 1 plus negative 2. And if we add those together, we get negative 2, negative 1, negative 3. So we get y to the negative 3rd power. Now make sure you pay attention to your directions. If it just says simplify, this is a perfectly fine answer. If it says simplify with only positive exponents, then we need to make sure that we get rid of our negative exponents here. And remember how we do that is we bring the x down, the negative 6 turns into a positive 6, the y to the negative third turns into a y to the third with a 1 on top. Either one of these are correct, just make sure you pay attention to the directions. For our next one, a little bit more complicated here. Okay, remember, fraction bar is like a set of parentheses, so deal with the top and then deal with the bottom from there. So we've got, for x, we've got negative 3 plus 1 plus negative 1 plus 5. So this would be x to the second power. And then our y on top would be 2 plus 1. So we'd have y cubed on top. On the bottom, we just have x cubed, so that's going to stay there. And then on the bottom, we've got y to the negative 7 plus 4, so y to the negative third here. Now from here, we can simplify this further. We always want to get it down to 1x and 1y in our problem here. If you look at our x's, we have 2 on top and 3 on the bottom. We could cross out the 2 here, and we could take 2 away from this, so we would just have an x on the bottom. Alright, with our y's though, it's a little bit different. We've got y cubed over y to the negative cube. Well, remember, we can get rid of the negative exponent by moving it to the top, and this would be like y cubed times y cubed, which we can add those exponents, we get y to the 6th. And this would be completely simplified then. Y to the 6th over x. A few more, a little bit more complicated. All right, as you can see here, we've got parentheses, we've got exponents. Remember your order of operations, you have to deal with the parentheses first. So we've got to break this first parenthesis down. We've got x, now remember how this works, is this 2 goes with both of them. And we have to multiply those, so this first x would turn into an x squared. The next one, 3 times 2 is 6. So our first set of parentheses turns into x squared, y to the 6th, and then we've got x to the negative 4th. Same thing up here. We can go and take x, negative 2 times negative 3 would be a positive 6, and y to the negative 3rd over, and then we've got distributive property again, x cubed, y to the negative 4th, x. Now there's lots of different ways to do these. If you want to get rid of your negative exponents right away, you can. Or if you want to add them together like we did on the last page, you can do that too. Remember, negative exponents would be like this x to the negative 4th. We drop down here into the denominator and make it an x to the 4th. I'm not going to do that. I'm just going to add our exponents together. So for x, on the top, we've got 2 plus negative 4 is negative 2, plus 6 is 4. For our y, 6 plus negative 3 is 3. And then on the bottom, we've got x cubed times x would be x to the 4th. And then y cubed times y to the negative 4th would be 3 plus negative 4, y to the negative 1 power. And then, remember, we got to get it down to 1x, 1y. We can simply cross out our x's because they're exactly the same. This y to the negative 1 power, we can move up. So this would be y to the 1st, and then this goes away. And our final answer would be y to the 4th power. All right, our next one, a little bit different. Okay, just to look at it, we have x to the a plus 3. We want to split up this plus sign, just so we can see if we can simplify these at all later. Remember, x to the a plus 3, that is like saying x to the a times x cubed. Our next one, we got to run the b through there. So we've got x to the b power and y to the negative 2b power. On the bottom, we've got x to the negative a, y to the negative a. Alright, from here, because both of these are negative this time, I'm going to move them all up so we can look at this just without a fraction bar in there. So then that would look like this. Then we've got a whole bunch of x's here. We need to add these together. So remember, we can go a plus a ends up being a 2a plus 3 plus b to combine all of our x's there. And then for our y's, we've got y to the a minus 2b. Could you put negative 2b plus a there? Yes, you can. I normally like to put my negative 1 in the middle though, or at the end, and always starting with a positive out front if I can. That's why I switched the order here. So this would be as simplified as we can get for this one. For our next one, lots of different ways to do this, okay? As you can see, we have scientific numbers here. All right, so what we want to do is we want to split these up and keep them as scientific numbers. Our first one is 4.2 times 10 to the negative 7th. That one didn't change. Our next one, though, is going to change. Remember, scientific means we've got to have a decimal. We've got to move the decimal, so our first number is greater than 1 and less than 10. So we would have to move the decimal to the right 3 spots. So this would end up being a 2.8 times 10. Now because this is a small number and we're moving the decimal to the right, that means that we're getting smaller. So this would be a negative 3. If we move the decimal to the left, like we will with the 2400, then it would end up being a positive exponent. From here, 2400, as we said, move the decimal to the right 3, so 2.4 times 10 to the third, and then we're going to take that times 1.6 times 10 to the negative 10. Now, if you notice, we've got a whole bunch of 10s here. We can combine every single one of those. 10 to the negative 7th times 10 to the negative 3rd would, if we add those together, we know for sure on the top we would have 10 to the negative 10 power on the top. On the bottom we'd have 10 to the 3rd times 10 to the negative 10th. That'd be 10 to the negative 7th power. And then from there we just got to figure out what number goes in front of there. So we can take 4.2 times 2.8 and we end up with 11.76. 2.4 times 1.6 gives us 3.84. Alright, from here, we still need to simplify this down some. Alright, we can take and divide 11.76 divided by 3.84 to get our first number, which is 3.0625. And then we got to figure out times 10 to the what power? Now, with this negative 7, remember we can move that to the top. And this would be 10 to the 7th power. And then we can just simplify our exponents here. Negative 10 plus 7 would be negative 3. So our final answer would be 3.0625 times 10 to the negative 3rd power. If you multiplied this entire thing out in your calculator, put parentheses in the right spots and everything, you would end up with the exact same answer. Alright? And that is how we deal with our exponents today. Any questions, make sure you ask. These can be very, very confusing. Be careful with your parentheses and your exponents on what you can add together.